পাচ্ছি।
আচ্ছা,
Okay, we are live now.
ওকে। Who is the other person? Hello?
Hi Ashif, could you introduce yourself to Zianda? Hi, can you hear us all?
I think Asif is not able to hear us.
But you can hear me, right?
Yeah, I can hear you.
ঠিক আছে।
He's an alumni or your friend?
No, I think from college.
Okay, okay, okay.
He pinged, he can hear us.
No, yeah, but we are not able to hear him.
That's fine. If he is in college,
Okay, fine. That's okay.
unless we have Q&A.
Hmm. What about Ankan? He's not joining?
No, he is, or like he's online, that I know.
Okay, he's online, but he's not
Yeah,
in the Hangout.
yes.
Okay. তোদের এখানে কি করা হচ্ছে?
আমার 12:30।
এ বাবা, তো তুই কি এখন পিএইচডি করছিস নাকি?
কি জীবন দুঃখময়।
হ্যাঁ,
হ্যাঁ, আর কি জীবন দুঃখময়।
সবাই এটা বলে যখন করে, তারপরে সব সুখ হবে, হয়ে গেল তখন সুখ হয়ে যাবে।
এটাই তারপর, ঠিক আছে, তারপরটা কেউ জানে না কখন হবে। আর তুমি জানো তো আমরা ইউটিউব লাইভে বসে বসে গল্প করছি, আর ওরা কোথায়?
না, আজ এক্ষুনি তো মেল আমাকে পিং করলো, ইয়ে কি নাম ওই ছেলেটা, আহ,
না, তার চেয়েও বড় খেললি আমরা ইউটিউব লাইভে, মানে আমরা এখন লাইভ, লোকজন দেখছে যে আমরা বসেই গল্প করছি।
ঠিক আছে, এখন আসুক সবাই, না করলে কি মুখ দেখবো নাকি? গল্পই করি, চলে আসুক বাকি সবাই। আর ইন্ডিয়া ফিন্ডিয়া কবে আসবি?
আমার এই মাসে আসার ইচ্ছে, মানে যত
আরে পাগলা তো।
যত তাড়াতাড়ি পারি। এ তো দেখা যাক। আরে পারমিশন নিতে হবে আগে, যে বাড়ি যাবো।
আচ্ছা আচ্ছা, তোর কি তুই তোর কি রেড স্টেট না ব্লু স্টেট?
আমার রেড স্টেট। আমি
পাগলা।
আমি ব্লু ব্লু পকেটে আছি, বাট আমার
আচ্ছা
টেক্সাসের চেয়ে বেশি রেড বোধহয় স্টেটই নেই আর।
আচ্ছা আচ্ছা, ঠিকই ঠিকই। ইউনিভার্সিটি গুলো সবসময় ব্লু পকেটই থাকে।
অবভিয়াসলি, বাট
হ্যাঁ, কোনো রেড ইউনিভার্সিটি মধ্যে নেই।
তাহলে তাহলে তো ইউনিভার্সিটি হতো না, না? না, আছে 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 ট্রাম্প ইউনিভার্সিটি।
ও ছাড় তো বাবা, ওটা ওটা এখনো চলে? ওটা কি আছে, ওদের কোনো বিল্ডিং ফিল্ডিং আছে নাকি?
কে জানে, কেস আছে ওদের নামে অনেকগুলো।
হ্যাঁ, অনেক কি শুনেছিলাম তো।
তোমার কি
এখন
খবর?
মনে হয় পড়ে পড়ে না ওটাতে।
থাক। তোমার কি খবর?
এই তো চলছে, টুকুর টুকুর এদিক ওদিক আর কি।
গরম কেমন এখন?
এই তো এখন আসছে এবার গরম, এখন খুব একটা হয়নি, আর কয়দিন পরে হয়ে যাবে।
তোমার ফোন এসছে।
হ্যাঁ। এখন তো এভরি ইয়ার একটা নতুন মানে রেকর্ড হচ্ছে আম্মা ওরে তোদের টেক্সাসে তো বেশ ভালোই গরম হয়তো না?
হ্যাঁ হ্যাঁ, একদম কলকাতা, একদম কলকাতা।
পাগলা
মানে
ঠান্ডাও ভালোই হয় বোধহয়।
অতটাও না, এবার বরফ পড়েছে দুই একদিন, বাট মানে ওই আর কি, মানে
বরফ পড়েছে মানে ভালোই তো,
তাও
ভালোই ঠান্ডা।
খুশকির মতো বরফ। বাট মানে গরম এখানে মানে হচ্ছে একদম কলকাতা গরম, এবং একদম অতটাই হিউমিড। সো
তাই?
হুম,
আচ্ছা,
চাপের।
চাপের আছে। এখন তো মোটামুটি ঠান্ডা নাকি?
এখন মানে এখন
পাখা
নর্মাল।
চলছে না?
না না না, এখন পাখা ওইটা চলবে না, ওটা কোনোদিন চলে না, মানে দ্যাট ইজ জাস্ট ফর শো, মানে ওইটা তুমি ওটার ফুল স্পিড দেখবে, তোমাকে দেখাচ্ছি না, ওটা ফুল স্পিড
দেখা
দেখবে,
দেখা।
দেখতে পাচ্ছি তো।
হ্যাঁ।
সো দিস ইজ দ্য ফুল স্পিড।
আচ্ছা আচ্ছা, এটা এটা অর্নামেন্টাল পাখা নাকি?
এটাই ফুল স্পিড, এরকম করেই চলবে, ঠিক আছে। এবার
আচ্ছা আচ্ছা আচ্ছা।
আর বাড়বে না, মানে এই যে এটা হয়ে গেল, দিস ইজ
হ্যাঁ,
ইট হ্যাজ অ্যাটেইনড ফুল স্পিড।
একদম ফুল স্পিড অ্যাটেন্ড করে দিয়েছে, বাহ।
এবার
আচ্ছা আচ্ছা
ব্যাস, এই চারটে স্পিড
আচ্ছা
কমে গেল, বন্ধ হয়ে গেল। মানে পাখা দিয়ে
আচ্ছা
কিন্তু হয় না, পাখা জাস্ট ফর শো। ঠান্ডা হলে
আচ্ছা
এসি, এসি লাগাও, এসিতে করো সবকিছু।
আচ্ছা আচ্ছা আচ্ছা।
তুমি বুঝতে পারছো এই জালি ভিডিওতে তারা কমেন্ট করছে।
না, তোর তো ভিডিওটা বেশ ক্লিয়ারই আসছে, খারাপ আসছে না কিন্তু। এই তেরা হাই হাই করছে, ওরা কিন্তু ভিজিবল নেই, কিন্তু তুই দেখতে পাচ্ছিস ওদেরকে?
হুম,
হ্যাঁ, only two people. কৌশিক দ্বারা আছে আমেরিকা, না ও ক্যানাডাতেই থাকে?
ও ঠিক আছে, কানাডায় থাকে আই থিঙ্ক।
আচ্ছা, আর বিবেকের কি খবর?
বিবেক দার ওই কোথায় জানি আছে, বস্টন।
ও বস্টন আছে, এই তো সবাই চলে এসছে, রেডি কর।
হ্যাঁ
আজকে তো মেশিন লার্নিং ইন্ট্রোডাকশন, তাই তো?
হ্যাঁ।
আচ্ছা ওকে, চল।
আর ইন্ট্রো, তুমি ওকে একটু চ্যাটে লিখে দাও না যে রেয়ার ভিজিবল নাও। ওকে।
বডি টিম আছে, লেটস
হ্যাঁ,
স্টার্ট।
আচ্ছা ঠিক আছে, চলো স্টার্ট করি। চিয়ান্দা,
বল।
শুরুতে একটা ইন্ট্রো করিয়ে নিই, মানে ধরো তুমি একটা
আচ্ছা
ছোট ইন্ট্রো দাও, আমি একটা ইন্ট্রো দিই, তারপর স্টার্ট করছি। অঙ্কনকে তো এখনো লাইভ দেখছি না, অঙ্কন ঢুকলে অঙ্কনকে ইন্ট্রো করে নেবো, বা লাস্টের দিকে করে নেবো, ওকে।
ওকে, ঠিক আছে, তাহলে আমি স্টার্ট করি।
হুম।
ওকে, হাই গাইস, I hope you are able to hear us. So I am Sianatullah Khan. I have passed out from 2008 batch. Currently, I am working here in Kolkata itself, but unfortunately, due to a very late night yesterday, I did not able to make it to the college today. So I've joined online from home. And today we have the session on introduction to machine learning. We already had one session last year. We had two sessions last year about jobs in general, and also one session on open source by Ravimba. So today, on request from you guys, we are having another session on machine learning introduction. So which is very critical as more and more job in India now we are actually transitioning from cost arbitrage. So all the most of the software engineering jobs that we had so far, it's depending on basically on the cost part. So we are not transitioning from cost to value. So this is the first stepping stone on learning from machine learning for increasing the value. So we now want people to work with Indians as a part of addition of value rather than only saving of cost. So I'll now leave it to Ravimba to take to give his introduction and take on with the course today's session.
Hi, everybody. So I think there is some problem, so I cannot hear you guys. Throughout the course of the talk, whenever you have any question, just raise your hand. So I will have in my screen mostly the presentation, I think, but I'm not sure when I go into presentation mode, I will be able to see you guys. But if you have a question, just like if you cannot even, I mean, if I cannot hear you guys, just type it here and I should get a pop-up and I will be able to answer. Okay, fine. Nice. Yeah, nod. That's the only way I can ensure that you guys are listening. So my introduction. So I passed out from Techno from 2010. I was from electrical engineering at that time. Right now, I am in computer science. I don't work. So I am exactly in the same boat as you guys. I'm still a student after 7-8 years now. So I'm in my PhD program right now. And I don't work on machine learning. That is not what I do. But I have had to work a little bit on certain portions of it. Part of when I was working in IBM research before Watson became Watson, we worked into the deep QA pipeline and here and there. With that, I'll start a little bit onto the introduction and what it is. So how the talk is organized is that, so this talk is a combination of a talk by Jason Mayo at Google, and also a talk by our principal scientist at Mozilla, and certain other talks. I have just like cobbled certain things up to make it easier to understand. How the talk goes on is like that. Initially, I'll go into what is machine learning, like what do we actually mean by learning, how does it differ from like all the buzzwords you hear, how does it differ from AI, or is it AI, what is deep learning, what are all these, like what are the differences. Then I'll go a little bit into more depth. For example, what are the algorithms used, a little bit of mathematics, nothing in the board, mostly into like what is going on in each of them, and if you have to learn more about each of them, what you need to actually go and read. A little bit of things like how you can play with the existing softwares, how you can actually build your own classifier, object recognition, these normal things which you can already find. The other things this will go on is that what are the use cases different algorithms are mostly used for, where you use classification, which algorithms are used for classification, and which is better for maybe something else, for example, prediction. So this kind of stuff. And at the end of the talk, or before the end of the talk, we'll go into more of use cases with a lot of videos and pictures of where these are actually implemented and used right now. You are almost everybody, all of you are familiar with where it is used and how you can actually use it right now. So I see Ankan has joined. I'll let Ankan do a little bit his introduction and then I'll start. Hi, Ankan.
Hello.
Yep.
Hey, you can hear me? Anyone can hear me?
Yeah, we can hear you, Ankan.
Okay, anyone and like the students can hear me?
Just raise your hand if you can. Yep.
Okay, okay.
Nice.
Like, should I volume myself up or down?
I'm good.
It's okay. It's okay. Ankan,
It's okay?
you can start your introduction. Yeah.
Okay, so hi, I'm a 2010 pass out from Techno India, and I did my bachelor's in electrical engineering (EE), and I think that's about it. That's pretty much that I can say right now. Yeah, how You guys came to the college on Saturday, really? Okay. Okay.
Good enthusiastic.
Yeah, let's not
Okay.
let's not keep them waiting.
Yeah. Okay. I mean, I'll just jump in some, like, let Ravimba talk a little bit, and then I'll jump in once in a while.
Okay, so I'm sharing my screen. You should be able
Okay,
to see.
Ravimba, I think you have not enabled your broadcast link.
No, it should be.
I don't see it on. It says the video has been removed.
Wait. Oh, so
Yeah, just so you know, this video will be recorded, and you guys can watch this video later also, and then you can shoot emails if you have some doubts or whatever.
yeah, I can see the live link.
Okay.
Okay, I'll just start my screen share.
Yeah, it's working now. Okay. Okay, continue.
Okay, can everybody see my screen?
Okay. Okay, I'll just.
So since I am in the presentation mode, I won't be able to see you guys. So you all can see my presentation link, right? Just write a text to me if you can.
Or raise your hand. I can see you. So. Okay. No, I'm just saying if you have a question or if you have some doubt, you can just raise your hand and I can stop Ravindra because he cannot see you. I can see you.
Sianta is saying no screen.
Yeah, I can see your video feed, but no screen.
Okay. Now?
Yeah.
Now we can see this.
Okay, nice. So
That's good.
Yeah, so let's start. So first, let us go into a little bit on the jargons, like what is artificial intelligence, what is machine learning. So what is broadly classified as machine learning is essentially machines are learning, and how do they learn? So if we go into more in depth, so most of you already have heard about Google Brain, AlphaGo, and IBM Watson. Are any of these artificial intelligence, or what are these? Are these already AI, or are they machine learning software or systems running on very specific portion? What we thought artificial intelligence is and what we have right now is not the same. There's a very small and narrow application of AI which falls mostly into the machine learning spectrum. So the common uses of AI, and I'll call it AI, but each of these are very specific machine learning problems, and which are right now solved by different means. So the first and the most commonly used is object recognition. So where is it used? Almost everywhere. In most of the countries where they have very high-tech car like traffic monitoring system, when your car goes in very specific speed or more than speed, it can recognize the car, the model, and with the camera, it can also recognize your number plate. That is object recognition. On a very basic scale, if you have orange and an apple, and if you point your camera to it, the video feed that you capture, you can run your machine learning algorithm on it, and you can actually recognize, okay, those are objects and those are specifically apple and orange. So you can actually differentiate between them. Next, we have speech recognition or sound detection. Those both are a little bit different. So speech recognition pertains to very specifically recognize speech, and that also can vary person to person. Sound is most into sound. So for example, if you are in a room where you have a baby and he or she is crying, and you are also in a room where it's recording a sound and there is a sound of opening a door. Those are both sounds, but for detection it can just be based, like just be detection of what kind of sound. Speech recognition is a little bit more advanced in this case, where it can be, one application can be just record your speech and try to understand what you are saying. So that comes to speech to text, becomes to the realm of text to speech to text, all these. The other portion is actually differentiating between people, what Google Home does. So on a single device, you can register your voice, your friend's voice, and it should be able to differentiate between you two. So that's a different set of problems. Then we have the other very broadly used and broadly abused category, which is part of natural language processing, or NLP, and mostly overused part of that is sentiment analysis. A very cool to demo example of this is that mostly what people use is that they build a sentiment analysis based on tweeted tweets, because that's easy. If you write something in 140 characters, you can just be, it can just fall into very few categories. You're not writing a complete like paragraph. So you can do a sentiment analysis based on that, and that can be using different techniques. Now, more into, if you go into creative uses of that, we have deep style transfer. So what essentially is that some of you have probably used Face App before. Anybody of you have used Face App before?
Okay, probably not. Not
Okay,
many.
okay. Or Prism maybe?
Yeah, maybe not.
Yeah. So what these applications do is that, so you actually take your own picture and it will try to redraw it in your mobile application using some famous paintings, maybe Van Gogh's painting or something like that. That is what Prism does. And FaceApp is that it will try to just give you some rough estimate of how you will look on after 50 years, after 40 years, something like that. So and probably you have seen some of your friends posting these kind of pictures in Facebook. So that is kind of a style transfer. So what happens in the Prism case is that you have your own image and it tries to see the edges and everything. It tries to redraw it on using specific style. So that is style transfer. We'll go into the depth of these later. And so in face swap, or just predicting face, that also learns from lot of faces of different age, and it tries to match your face with the one it has learned before with that specific age and just create something. So that is another portion. We have prediction, where it tries to predict, and that can be mostly numbers. But how is it useful? For example, all the stock predictions, everything, you can try to build machine learning models which do that. Some people do that, some people don't, because everything has a pros and cons. Another popular and pretty successful now application of machine learning is in translation, and that is between languages. So how we used to do translation before the machine learning era came in was that you had a specific set of different languages. You had language pairs, and you kind of build a rule-based application how you should translate. So that's why we used to get like hilarious translations before in Google Translate. Even now you get that, but now machine learning kind of actually associate different words, and it can give you less gibberish translation than it was giving you before. So it can learn from its own mistakes. Something on that sort in advanced cases would be it's called GANN, or GAN, Generative Adversarial Network. So it can kind of not only learn by its own mistakes, it can play against each other. So that is something, another thing I'll go into later with one example. So these are some of the things which are machine learning is being used. I mean, right now machine learning is literally being used for every application, even though if it is a right fit or not. So that is also one portion of our talk where we need to see that, okay, which portions are actually proven to be useful for machine learning, and where you probably get a better chance of getting successful models out of machine learning. So in very broad terms, when I say machine learning, it's just a system that can learn from experience. So you can actually write a program that can be a rule based and based on different set of parameters you already gave it. But a machine learning model will be one step further, where it can actually learn from the experience. So not only based on the data you gave it, but also from what it produced. So not just specific rules, it can also learn from patterns. So essentially, it's all about predicting different stuff. So when we are predicting stock data, it's predicting different numbers. When we are trying to build a creative algorithm, for example, style transfer, then you are trying to predict the face. Then you are trying to predict which style actually works with that face. So it's all about prediction. And the thing about machine learning is that the more data you have, the better your predictions will be. Works with that face. So it's all about prediction. And okay, I was getting a echo. So essentially, the more data you have, the better your prediction will be. And the machine learning system learns the patterns from this data. And when you provide new data, even which is not according to your rule, you have no rule specific to that data. So the program doesn't know what to do. It should be able to come up with its own rules based on the data you already gave it. So that is kind of pretty powerful. But how you actually do that? So take us like two very small pseudocodes, not even pseudocode, like what you normally do. So when you are doing for a normal traditional programming, you write explicit rules. So when you so this is a very common example. Right now we have seen how less number of spam emails we get, and when we were in school, not even college, uh, we used to get a lot of spams if before Google came, before Gmail came, and it was like a daily way of like daily you have to open your email and just delete all the spams. So one way of actually dealing with spam is the spam filters, which used to work like you write a specific set of rules based on this example is based on keywords, and you can write different smart keywords. For example, you can use regular expression that okay, if it's something similar to that, similar to this word, or if some variation of this word is there, some variation of these things are there and everything, and just specify them as spam. So you can be as creative as you want, but those are still your rules. Maybe those are loosely based rules, but still rules. If something which does not fall inside your rule but still is a spam, that will just pass through it just because you have not seen that kind of attack before. So it can pass your rule because rules are made by you. So if it can fool you, it can fool your rule. Not the same with classifiers. So if you try to classify some emails, and obviously if you try to train it, you will essentially write the rules and you will essentially tell them, okay, when it output something, there will be something wrong, something right, and then you will train them, okay, these are wrong and these are right, and essentially we'll try to again and again run through it and get better, and essentially it will reach a stage where it can get new kind of spam errors which it has not seen before, and it will still try to classify them. So taking on the jargons, so what is deep learning? Deep learning is another specific method, a very specific method of implementing machine learning. So deep learning essentially takes how you actually build the machine learning pattern and applies to it on very specific domains. For example, if you take this picture and you see how it goes, is that deep learning is a very small subset of machine learning. And like we said, artificial intelligence is, you can say like all of these are part of artificial intelligence. That's a like loosely based term of different things we try to achieve by machine learning. So they all are linked with each other, and ultimately they are supposed to enable artificial intelligence. So how to actually choose your data to train your machine learning system? And you can see these slides are from Jason, and yes. So to train anything, it's not rule based, right? So we need to actually give it a data and let it learn how to actually recognize things. For example, in this one, we need to tell it that okay, this is an orange, and we have different features. What are features? Features just properties which it will learn to actually recognize orange. So it does not know what is orange. It cannot see the color like us. It cannot see the shape like us. Those also can be featured, but for us it's not. So the only two things the machine learning software knows is that its weight and its color. So these are the two things, the only two things it knows. So if I give it a brick with an orange color and which weighs exactly 340 gram, it will classify it as an orange. And like, make no mistake, it will classify it as an orange. So features are useful, but features are also very important. And these are not hard and fast. You need to come up with, you need to decide with what will be your feature for your specific problem. Now, you might just say like how what I said, that okay, it just knows the color and the weight, right? So you can say that okay, let me take more features. So let me take, okay, it has color, it has weight. Let me take something like shape, that okay, it should be this shape. Or let me take something that it will have a green colored leaf. So first it will have a leaf, it will have a color green. This kind of things you can encode all of them. So what stops us taking a lot of features? So first, if we have those features, how do we actually incorporate that? So one of the easier ways is that, okay, we have X and Y axis, we have weight and color, and we just classify based on that, okay, what feature of each of the data that is given to us are in which place. Here, if we plot all of them, the apple, based on its weight and its color, falls into a different cluster than the oranges, than the peers. So all three are in different place. So we know that whenever there is a new data coming in, so these are our training data. So we trained, and now we know where these clusters are or how these are clustered. Now we have a new data which comes in and which fits into any three of these categories. It will fall into any one of them, and we can just classify, oh, based on our prior knowledge, that okay, this is an apple or an orange. Now, like I told, it's very useful to actually choose correct features. If you choose wrong feature, it can just be as chaotic as this picture, and you won't be able to actually identify them. So before I actually move to non-trivial data, do you have any questions, anybody?
I actually have a question. So if
Yep.
yeah, so essentially when you talk about classifiers, right? So how can we imagine classifiers to be? Are they like human experience that we already see something, we learn from it, so we try to understand what is the next thing, or the classifier itself is kind of some type of rules?
Based on how you encode it. For example, the example I gave it, it's based on human knowledge. So I already knew the
Hmm,
apple and orange, so I just encoded the knowledge I already had,
hmm.
and I made it. So it's not like a binary rule. So we only just knew, and what that one does is that it just classifies on a different cluster, and you just know based on previous cluster that okay, if my new data point is near to this cluster, then
Hmm.
I can just like say that okay, that is apple or orange.
So we can imagine that to be kind of a mapping between features of the data,
Yep.
feature extract features of the
Yep.
data. Is that how we can imagine classifiers to be?
Yes.
Okay,
Initially.
okay, initially. Okay. So how we means my actually question is like classifier is a kind of a model, right? That we use to analyze the data, right? So
Yep.
is that is the understanding. So how do scientists or how do machine practitioners how do they go about building this model?
So for example, I'll give you
Hmm,
like this example only. So I have two datas, right? So I have just like a like two numbers.
hmm,
Weight is like a number to me, and the other one is a number to me, right? So
hmm,
I encode that as a matrix,
hmm,
and when I have all those, I try to calculate the difference, like the new data which will come to me, it's a
Hmm.
difference of the distance from what I already had.
Okay. So new data should have those properties, right? Like if I give them a new data, say about if I give them an image of a brick, I need to give them that color and weight also, right? If I don't give that,
Yes,
then it will not make any sense for them.
exactly. So if you have a new image, so think of it like a real application. So real application probably will be just a mobile application. You take a picture and
Mm,
just put it. So
mm.
for this one, the weight won't anyway. So for example, if you take a picture, so I can get the color. So I have the color, whatever color it is, and you can just give it how much weight it is. So it will
Okay.
actually just take those features or whatever feature you encode to your application.
Okay.
So it does not know anything.
Right. Means
Yeah,
for any new data also the features must be present. Like even to for the classifier to take a guess, those features has to be present in the new data that we input, right?
Yep.
yes.
Okay.
So I think what he means is like the more number of features that you can define in a system, the better it is. For example, like as I said, if he is making a whole directory of fruits, you would obviously give the color and the shape and how it generally looks like. But usually colors are common. Like orange can be a bunch of fruits. Sphere can be a bunch of fruits again. But you can be more specific. Like okay, you want citrus fruits, and that could be another dimension that you add in a data set that will actually reduce your vision to only few fruits, not all of them. So
Okay.
it's kind of like you need to, I mean, as a scientist or as a data engineer, you can keep on adding as many features as possible, and it is better for you
Okay. Okay.
to add more features on the.
Okay.
So,
So
so there is a question from Ashish, I think. So
Yeah.
it's a generic question. It says, so what does a person need to know to get started with machine learning?
So if I answer that, then to just run these examples, you actually don't have to know anything right now. So most of the theories I'm gonna tell you, so like how I just answered Sianda, that okay, you just build a matrix, you calculate the difference. You actually don't even need to do that. There are libraries available in Python, scikit-learn, NumPy, and lot of like all the Anaconda build has all these libraries built in, and there are tutorials. You can actually just write 3 line of code which takes all these in and it will actually handle all these internal data structures for you. So you can actually just write okay specific, tell these okay these are my data, these means this, these are the orange and these are the apple. You train on it and you run it and it will do that for you. So if you just want to experience that, that is fine. But
Yeah, yeah. Sorry,
yeah,
go ahead.
yeah, yeah. So but if you want to go in, if you want to go beyond the whatever example that is there is already available, you need to learn a little bit about what you want to do. So we will actually cover that in the slides, because
Mhm.
not every problem has a single way of approaching them. So right now what I was telling, there are ways like so this is classification, there are regression, there are sequencing. So every problem does not have to be like a single way of approaching them. So if you have a project, so that was I think the second question, then you need to see which one fits your purpose and actually read on it a little bit. You don't have to understand the math, but at least read the math, so that when you are actually looking that okay how other people have done it, you know what they're doing. Otherwise there are things like overfitting, underfitting, those things will cover very small in detail. You won't understand what is going on unless you write the everything by yourself.
Yeah, I think if I have to take a step back, what they want to know or what I can tell them from their question is, I think all you need to know at this point is just basic geometry. Okay, so the reason why I'm saying that basic geometry is when you look at a problem, intuitively, if you don't have to write a bunch of code because you probably don't have background or you don't need background, but anyways, but if you just look at a problem statement and just draw it on a white piece of paper, all you need to do at the end of the day is some basic geometry. Okay, now the geometry could be complex, obviously, complex because it for most of the cases, it may not be limited to 2 dimension. It would be 3 dimensions or more than that. But for the starters, just think of it as a basic coordinate geometry problem. Okay, so I can give you an example. Like after you get off from this session, you can just write basic equation or math to just draw a line on a piece of paper. But there are, okay, so let me rephrase that. So if you have a piece of paper and then you add a bunch of random points here and there, okay, just make a coordinate x and y axis, put 0 comma 0 anywhere, and then put a bunch of random points here and there, okay, and then try to add a line which separates the whole number of points into two equal 50-50 groups. And this seems like a very easy geometry problem, but this is a classic machine learning starters problem. And once you start solving these kind of things, you're pretty much there to actually in a good shape to actually work on a big projects or contribute in a large scale. But at the end of the day, you would do this. You will just have a bunch of points. You will draw lines here and there, try to see, what forms the clusters and things like that. But and at the end of the day, it's just geometry.
Okay, I'll go back to the slide and like slowly we'll go to like the pitfalls. So yeah, so coming back to our data. Um, so now we have established that having more feature points are better, right? So how do we actually visualize all this data? Like what Sianda was asking, how do we actually encode it in a program? So mostly we see all these as a two dimension. Like I said here, X and Y axis. So these are all in 2 dimension, right? But most of the machine learning problems you will have, like Ankan was telling, that you have more features. How do you encode them? These are more, all the features are, each of them are their own dimension, and you have more than one, more than two, more than three, a large number of dimensions, right? How do you deal with that? So little bit of note, more dimensions can often help to actually segregate the data points. For example, when we were clustering, since it was in 2D, you can just see how they were clustered using only two features. Now, if you have 3 or 4 or more number of features, you need a bigger plane to actually put those clusters different from each other. So it's not only X and Y axis. So it's easy to separate for us in that way. Now, the most problem, so the classic problem we'll face when dealing with machine learning is how to actually find the data. So most of the problems we discuss can be solved pretty easily using classical algorithms if you have exact what is to expect and what do you like the previous result. And so the most problem in machine learning is you need to have like precise huge number of data to actually let the machine learn. So one example is here is that if you wanted to recognize cat, you need like at least 10,000 example of images of cats before you have a chance of getting it recognized, or at least remotely getting recognized. And here comes the interesting part of data cleaning. So when I say image of cat, it's not just you taking an image of cat or Googling images of cats, because they have image of cat, of course, but with them a lot of other things. So you and I can just differentiate, okay, these are cats, the machine can't. So there comes the part where you actually have to clean, sanitize the data, actually mark out which portions are cat, get it out, build your own data corpus, and then work on it. That's why this is a problem, because these kind of things take a huge amount of time and effort. That's why getting good data sets are either expensive or time consuming or costly, or sometimes all three of them. And that's why whoever holds most amount of data is kind of the king here. Now, a machine learning system does not know what it has not been taught. So like what I was telling you, that specific picture, if I tell them that if I give it a picture of brick and I still it matches the weight and color, it won't be able to say it's brick. But if we had a separate set there with apple orange and a brick, where we could have just encoded maybe a different feature or even the same feature but with different weights, then it could have easily told us that okay, this is a brick. So an ML system cannot predict unless you specifically train it to catch that. So these are few example videos you should see, and they explain very specifically of how you can use machine learning. Like right now, you use machine learning. So I'll share the slides later so you can actually have a look at all these. I wanted to keep them so you know where to actually see the videos. So learning styles. So this is where we come that okay, which kind of styles, like what kind of style is important for you for which kind of problems. So there are broadly two, now even three kind of machine learning, broadly two kind of machine learning methods, not methods, like styles to use. One is supervised learning and another is unsupervised. So a very short example is that in supervised learning, a human or a what we call human loop actually tags all this data. What is called by tagging? So when I say this apple or this orange or this whatever is 200 gram and this is apple or this is red, so we have a large number of image where somebody built that. We actually went there and tagged that. Okay, these are these are that, these are that. And so this is called supervised because we actually built that, we tagged all those data, and from that the machine is learning. By definition this is more efficient, but uh, the unsupervised learning, but it's more efficient, it's always better to do if you can do it. But often we have a large number of data which are not tagged, so you're not tagging all them, and it's very like time consuming and expensive. So we need to come up with a way where the machine can tag itself or at least can do that. So there comes the unsupervised learning, and so it mostly relies on different kind of methods to kind of like clustering to kind of measure that okay, this is similar to the data point we already had, and this is similar to what I have already seen, so this probably is apple, and I will try to de- like uh, I'll try to I'll try to the further learnings are based on the specific learning that okay, I'll try to take that as apple and I'll try to learn more on top of that. So that is unsupervised learning, that is often buggy and often like most of the times not as reliable as supervised. But then again, if you have a very large number of data or data which you cannot tag physically, not possible, this is the way to go. And there has been a huge push towards this kind of research. Now, in the interest of time, I'm going to go a little faster on some of the slides where I think I can just tell you the concept and not go in between. If you have any question, just like give me a ping and I can explain. Uh, so another portion, this is, I just wanted to like tell you a little bit. So reinforcement learning, these are all part of deep learning. And one of the very easy use cases you will probably see is solving games. What reinforcement learning is that it's a kind of reward and punishment system. So if it does something, it just guesses something and it tries to solve that. And if it can solve it, it gets a reward. If it doesn't solve it, it gets a punishment, means it just goes one step back and knows that the previous approach was not good enough. For very small example, Mario can be easily solved with reinforcement learnings, and most of the like board games you see is solved by that. Some of you have seen probably Google's AlphaGo, which beat the world champion in Go game. That was application of reinforcement learning. And in most of the research or like engineering problems, it is used to kind of solve globally optimal problems, where most of our brute force approaches solve locally optimum problems. So how does it all work? So a machine learning system mostly learns patterns based on the data you gave it. So for example, this is all of you have done in your actually you have already done this or still doing it. So most of you have already done different lab classes, right? You have built graphs and drew graph, right? How many of you, I'll go back. Okay, so how many of you actually know the result, what is supposed to be the graph look like, but You are not getting that. So you just draw the graph, kind of extrapolate where the results should be, and draw the graph. But your results are not that. So there you extrapolate the graph, right? You have done that in lab classes, right? I mean, we used to do that when we did not get correct result. So I'm assuming you guys also do that in labs where you don't get proper result. So here, what happened? You can see the slide, right?
Yeah, now we can see. Now we can see.
Yeah. So here, what happens is that given an x and y value and given a number of x and y value, it tries to predict where the next one will be. So based on previous systems, it tries to guess the next one. So it's a regression and it tries to calculate the line. The second one was try to cluster. So you have different lot of data points and you try to cluster them and you have a line in between, and you know that okay, anything beyond this is probably apple, anything beyond that is probably orange. There will always be outliers which are apple but has the properties of orange. For example, the specific property you chose for orange, maybe an apple looks kind of like orange, or which has very similar weight like orange, and which color is near to orange. That might be into the clustering side of the uh, orange side. So those are outlier. There your model will fail, or you will just get a like error, but even then it is pretty good. And it's not only like a line, it can also be different ways, and it can be complex functions as well. So another thing is that another way we use it is called k nearest neighbor. It tries to calculate its nearest neighbors and tries to actually draw the differentiating line based on its neighbors, not on just based on where the clusters are. I'll very quickly skip through neural network and deep learning because it will be hard to maintain all of these. So basis of learning, neural network was loosely modeled on what grows on in our brain. But quickly scientists find out that it's not very easy to mimic that. So they dedicated the whole portion to a very narrow field. What is that? So if you go about neural net, or what happens in a neuron, it's a just weighted input. So if you have a previous result, if you have a expected result, it will try to weight and rank your results based on different activation functions. And what happens when you have deep neural network, or actually multi-layered network, what happens is that you have a lot of different layers, and one layer gets input from the previous one and tries to predict on the previous one. So what happens is here is that the first layer actually gets a very broad section. For example, it just gets the skin tone, maybe just the color of the skin. The next layer actually can define that, okay, from color, which more properties. So color is of which face or hand or which portion. And essentially each layer has very specific inputs which are based on the previous layer. So it can actually kind of drill down and give us very specific answers. So that's why for some cases, deep neural networks are very useful. For some cases, it's absolutely not useful. This is a nice video which you should see later to actually just see in an animation how it works. And this is kind of you should see, but there is no time to actually explain what convolutional neural network is. So different types of machine learning output. So this is what I was telling you, that how you should actually choose your problems. Sorry, choose your solutions based on your problem. So we have broadly four things that is going on here. One is regression, just predicting numerical values. So for example, predicting price of a house based on real estate, based on different factors. Then we have classification, which is just classifying different data. For example, what is apple, what is cat, what is dog, what is human, what is car, what is truck. Clustering is kind of prediction based on your previous thing. For example, all the product searches at Amazon based on what you have been buying. So these are like clustering your choices on different clusters and try to give you nearby data points which are the products Amazon shows you that, okay, you bought that, so probably you are gonna like it. That probably is your cluster. So sequence prediction is that this is also used in autocorrection and machine learning translation. So like what comes next, kind of like doing association between text. So when you have a continuous, before I go there, anyone have any question? Okay.
Yeah, I actually wanted you to tie back the unsupervised learning,
Yeah.
the Apple example, to the orange example that you gave us. So when you say that unsupervised learning is working through unlabeled data set, right?
Yeah.
So in the previous example that you showed, you said that we are actually labeling the data like this is an orange, this is the property of the data. So when we give them unlabeled data set, like what actually we are giving them? Just the properties without classifying it, like 250 lbs orange, and we are not labeling like orange is a color, or 250 is the weight. Means how do we actually feed them?
Yes. So let me actually rephrase. Unsupervised in that example will be, it's not completely unsupervised. So it will be that you have some amount of data which are tagged, but you have also a large amount of data which are not tagged. Right. Now, if you make your system learn on those only small amount of data, you have no way of actually saying that if it is at all classifying it correctly or not, if it is at all saying apples are apples, if it's not just saying that, okay, taking any orange and just classifying it as an apple, right? So if you have some amount of classified data and lot of unclassified data, sorry, untagged data, then in unsupervised, what it does is that it takes all those unsupervised data, goes through classification one by one and ranks them. Okay, that with this amount of confidence, I can say these is apple, these are not. So when it does that, it creates new amount of data near the previous one, and it incorporates the one where it has more confidence that, okay, this is part of that, and that is how it starts building.
Okay.
And that is also the reason it fails, because sometimes it just overfits. It just tries to guess that, okay, that so remember the example where we had one outlier which was
Mm.
an apple but in the orange. So unsupervised will just think it of an apple and it will classify that as an apple. But next time another sorry, and classify that as an orange. Next time an apple comes in which is very similar to that one but visibly different from of original oranges, it will still get that as orange because it is similar to that faulty data, right?
Okay. So how does if I give an example of unlabeled data, so I will give the machine learning like I will say that orange and say weight is like 240 grams. So I will just give orange and 240 grams as input, and without saying that this orange is the color and this is the weight. Is that correct example of untagged data?
Yes, it will create the data set for you, not
Okay.
necessarily that it will be correct. So yes.
Okay.
So they it's, I mean, it sounds fancy, but there are only like few unsupervised like algorithms we use, because there is no actual way to actually show that, okay, this is apple and orange. So we can just cluster them based on how similar they look. For in mathematical term, how similar means just how, what is the like difference between weights. So if 313 gram is something and something is 335 gram, are they similar? Are all other apples are similar, which we already knew, like the that within the tagged data, if all the tagged data are maybe only 2 or 3 gram difference between them, and we have untagged data which are only like 2 or 3 grams difference between them and also in the same color, then we can kind of assume that, okay, that will be. So this is how the clustering portion works, right? So you can do clustering, you can do like Gaussian mixture models. So there are only a couple of ways you can do that.
Okay. Okay.
Okay.
Okay. Fine.
Yeah. So something else I wanted to ask you, if it becomes too much text or theory heavy, I actually have some cool use cases where it gets more interesting and you might get interested. So whenever you feel sleepy, raise your hand. I'll go to the video part. Okay,
Yeah,
is
I
it
think
okay?
you should play some video.
Okay, so we'll come back here. So where people are using machine learning, and we kind of crossed how we can do that, but we can always come back here. So I'll just go through some examples and kind of tell you what I know, what they're using. So where Google uses that, very so these are obvious examples you already almost all of them you use. If you use Google Photos right now, you can actually search by using people's names, and it will show you those pictures with those people in it. If you use Google Inbox, it can actually give you context aware smart replies, which you can just select and it will send it. So these replies are based on the text or the emails you are getting, and Google actually reads and analyzes those. And so another example is the robot's hand-eye coordination. So if you have a lot of things in your table, we really know that how the depth works, and which is, if my phone is behind something or over something, we know that. So a robot has no way of knowing that, and it also has no way of knowing the depth. So we can actually teach it to actually know what it is seeing and how it can actually translate that to its robotic motion. Google mostly uses that to improve their consumer experience. It's kind of right now embedded almost everywhere. This is an example. I can show you a better example. This is an auto draw. So what you can do is that you have a blank canvas. Maybe you try to draw a cat. So if I try to draw a cat, I suck at drawing. So my cat, my elephant, everything looks kind of similar. So AutoDraw can predict what you are drawing, and it can give you that drawing immediately. If I draw a cat, it will actually give me a cat if it can recognize my drawing. So it kind of learns from a huge number of handwritten data sets and tries to predict from those data set what you are actually drawing. Of course, it does not succeed all the time because it does not have everyone's drawing, but it's pretty good. This is Google ATAP project, Project Solid. So what you are seeing is that this is gesture recognition. So they are doing all these like in the air, and there's a chip. It utilizes something similar to radar, so it actually just sends ultraviolet, or sorry, it just sends like radio frequency out, and that bounces back. And based on the vibration, it tries to build its model and tries to say that okay, if it is something like pinch, then the vibration should be, the pattern should be like that. If it is sliding, then the vibration pattern should be like this. And this is a video where it actually works. Some of you have seen Google I/O. Pixel Buds came this year, and this can do live translation. So you can talk to me in Bengali, I will hear it in English. I can talk to you in English, and you will hear it in Bengali, provided you also have a Pixel Bud. And everything goes to cloud, and it just does machine learning on the fly. These are more interesting things. So Google Lens is that it just takes a picture, it in near real time tries to predict what that is and give you context aware information based on that. That's Google. Now what are others doing? More interesting things. So there are a lot of things in academia going on, but more on that, you need to know what is going on in real life. So this is a video from Boston Robotics, Boston Dynamics, I think. So this robot can actually do a backflip and still balance on it. This is not normal gyroscope anymore. It uses a plethora of machine learning information, or actually learn how it will land or where it should balance its weight and all of these. This is what I was talking, style transfer. You have your favorite trusty dog, you have your favorite trusty Van Gogh picture, and you have a picture where Van Gogh drew your dog, or try to draw your dog like a starry night. So that picture is starry night. So this is done by machine learning. Nobody actually saw or like sat with Photoshop and actually did it. And there are interesting applications with that. So very soon, like within this year, next year, you will have a Photoshop where they will have a plugin where you can actually take a picture in the morning and you just set the mood that okay, night mood, and it will automatically create those scenes for you in your own taken picture where it is night, exactly like night, where it's light glowing and all, like everything with how it looks in the sky and everything. So those are based on machine learning and style transfer. There are a lot of work in video generation. So we are already in that age where we can actually generate videos, and not only generate, we can actually change faces of videos and all these. So these are becoming a real problem with fake videos, as we see. Now, this is a very interesting portion. Uh, what what comes to your mind when you see this video? Sorry, see this picture. So what you see on the right is that machine learning software or just algo tried to, yes, sumo wrestling. Thank you, Ashif. So that's what I see as well. But the machine actually was more poetic. So this poetic learning algorithm tried to build a poem based on what it is seeing in the picture. It has no context awareness, it has no idea what is going on, but still, based on literatures, based on the object on the screen, and trying to infer and trying to guess what object fits with what kind of prose in a literature, it tried to come up with this prose on the right. He was a shirtless man in the back of his mind or something. I'm bad at poetry. So these are some of the things which goes on. There are other ways. So most of the things where we are doing with image is you can translate things, not only like words. You can actually point your camera to any specific object, it will recognize the object, send it to Google Translate, and get you what you are seeing. So these are different kind of games based on that. This is my favorite demo because we just released something similar. So what you can do is that based on different objects, I can recognize those objects and I can create a new object based on machine learning. So what machine learning does is that it recognizes the object, sends back to me, and I can just create a new augmented reality application based on that. So these are some of the examples. This is what I was talking AlphaGo. So this takes those same machine learning challenges, same problems, and it builds those models, but in scale, in a huge scale. So these are different kind of challenges which will come through eventually once you are gone through like normal challenges, how to predict the image, how to predict something. Now you have to do it in a very large amount of data, and it becomes little problematic. So these are the kind of things what people use. So Spotify uses machine learning to customize content to show you what kind of songs you probably like based on your previous experience. Netflix uses that. So all these are trying to guess what you are gonna see or what you like. So these are all predictions. So Project Muse is same kind of prediction, building 3D models based on what you already see based on images. And we also have how you actually converse with users. So this is a project by Disney where you can interact with a physical object like a book, and it will, every page you turn, it knows where you are turning a page, and it gives you like a running narration of that. Westworld had an awesome VR experience where they had machine learning to actually build the storyline. And of course, Google has a lot of things which it does for machine learning. So any questions till now? So these were all just use cases. Now we are going back to the more uh, boring part of how these work. Any questions? Okay. So I'm actually already running bit of time. Ankan, how deep should
Yeah,
we go?
about like 15 minutes, maybe 10, 15
Okay,
minutes.
so going back to where we were. So here we just do linear regression to fit a line based on the most number of dots here, or for us, our case, most number of data points, and try to predict the output based on that. When we have a classification, our input layer, if that is a dog or cat, and we have inputs, so all these layers have different activators. So all these neurons are specifically just different features. So when we have the first input, we have hair, paws, whiskers, and then if you have all of them, then output a cat. And now all these layers check more than these features, but essentially they all will check the different features it will have. For example, the first one will probably check all of them, and whatever it gets with different prediction, so it will probably get all hair, paws, whiskers, and a lot of other things. So extra data you have, it passes through it and goes to the next one. So the next one is more choosy. It will try to see only few features. Maybe it will get two features. It maybe it will get hair and paws, but not whiskers. But it got a lot of other features. It will pass it to the other one. So that is how it essentially differentiates between hair, cat, and dog, because some of the features will be also over. Most of the features actually will be overlapping. And something you need to understand, how I am telling you is that okay, these are features, and essentially you get output dog. That is not how you actually get the answer. That is, yeah, and that's not how you actually get the answer. You will get the answer as a number, and that's just a probability of estimation. So how much probability is it, a cat or dog? And it's on you how you interpret that answer. So we have to come back to estimation of probability. So a better model will always have a very good probability estimation where it can understand it's overfitting or underfitting that data. So if you put it very low probability, even though if you have a lot of data, if you have trained it properly, even then it will show you garbage value because you have the probability estimation wrong. And at the end of the day, it's on the developer, on you to actually know how to interpret that. It will just give you a number, certainty that okay, it's maybe 30% sure it's a cat, it's maybe 20% sure it's a dog. It will never say it will be 100 or 18 like that. It's not like 30/70. So that is kind of what it will get. And you need to understand, you need to build your application based on that. Okay, this is my threshold. If it goes here, or if I get good enough, so that is on you to actually interpret the data. So these are ML algorithms, and these are optionals. You just skim through that because we won't have time. But I'll just go through just the bullet point of what they are, why they are useful. So regression is linear regression. Most of you who are from electrical electronics engineering or even CS, I think you had to read these. So it's just based on relationship model. Instance based on decisions with instances. So one of the example we did was nearest neighbor, and that is an example of instance based. So decision trees based on previous decisions of what you took. So like for example, you have dialectic acyclic graph, conditional decision tree, all these are decision trees. And then we have Bayesian. I'm not going to explain that. Clustering is K-means clustering, and we also have association rules based on a priori algorithm, which I'm also not going to explain. So these are the things we have. We already talked a little bit about perceptron. I'm not going into what they are, but if you remember those image of how each layer takes previous layer's input and passes it through, so that is what mostly perceptrons work. How? So deep learning is the same thing, just its perceptrons are now multi-layered. So each layer, one of those perceptrons gets input from the previous one, and it just drills down based on the previous one. And this is actually important. Remember in the initially we talked about your data can be multidimensional, and Ankan also talked about if you have more number of features, it's better. But how do you know which features are important? And let's just assume that we cannot physically go through all the data and just like manually tell that okay, these are important, these are not, or just go through whatever output it is giving us every time, and we cannot do that manually. If we take that into account, then these are methods, for example, principal component analysis, which reduces all these dimensions and gives us, and this is a little hard to kind of wrap your head around. This gives us a specific number what you can uh, substitute on your specific features. So, for example, if you have 6 or 7 features and you run principal component analysis on it, it will give you like a set of new feature maybe, or like you just understand is a new feature. It will give you a number of numbers which you can use to work for your second layer or whatever you're building. These are useful when you have a lot of features and you want to reduce the dimension. These are also not really correct if you get the wrong features and reduce the dimension from them. Uh, I'm not going into ensemble too much. So this was in short. Yeah, so this was in short what we can do with machine learning. I just really ran past the methods here. Uh, but all these, based on whatever your problem you're solving, are able to do most of the demos you saw. So any question on that? Okay.
Okay. Any question about anything
Ankan,
about this?
I finished in 10 minutes.
Yeah, that's good. This topic or any topic or anything actually. So what we are trying to do is with every talk, we are trying to have this whole topic of discussion, and then at the end of it, we'll have question answer on based on that topic, and then followed by another sort of question answer of anything. So just so that you have a space to talk about, or you can talk to us in person about anything else. So if you have some questions, you can just shoot right now.
Yeah, I think it was a very good talk, and we came to know about so many different ways how machine learning is being used and how and what are the different algorithms. I actually have a interesting problem if anybody is interested. So currently, I'm working on OCR extraction of data from insurance card. So we get the OCR data from the Google Vision library, but what we want to do is actually classify it as the first name, last name, member ID, and all these US insurance card data. So currently, what we have done is actually some rule-based thing we get from the data, but it will be interesting to actually do some classifier training on it and try to extract that from there. I have around about 10 or 12, but unfortunately, the data is very less right now because insurance data is very sensitive and we can't get that. But if anybody is interested on trying out, I will just in the data for the names. I will just remove the names of the customers. But if anybody there is interested to work on this text classification problem from that data, we just want to categorize the insurance data into the different parts so that we can know after scanning the OCR like this is the first name and this is the. So shoot me up. So I'll share you the data and then you guys can, if you can work on that. So I tried the name classifier on that, which is from the Python NLTK. So it was kind of giving a lot of false errors on that. So maybe we can do some type of training because the type of data it is like a name classifier works with title case paragraphs very well, but the way the Google Vision is returning the APIs, I mean the OCR information, the name classifier is having a lot of false out. Anyway, this is something that if anybody is interested to work with, I think it will be great.
So I wanted to make a disclaimer. if I was in your shoes today in my first or second year, maybe, and I would have seen this session, it probably would have like too much information in 1 hour. Uh, so my advice is, don't worry. This is not as hard as it sounds, or we make it sound. It's really not that hard. Eventually, when you start dipping your toes, at least from application perspective, it's pretty not easy, but it's okay to actually pick it up and actually try your hands. So just as an application perspective, you don't actually have to know the algorithms to work on it. People have already coded almost all of them. You will have be able to find and actually use that, but it's still better to have idea about the algorithm so that you know what tools or which one to use for which problem.
So, Ravimba, how much of statistics, basic statistics, is required actually to understand like what output I'm getting from the algorithm? What amount of statistics is required? You mentioned Bayesian. You did not go through the details. So, like we understand probability is absolutely required. So you understand the output accuracy. And what else you saw the regression and clustering? Ankan talked about geometry, so he was mentioning the clustering part there. So means what is good to have in statistics so that it will help us fundamentally. We don't so learning the detailed algorithm. I think it will take a lot of mathematics. I don't think I know a lot of us might not be able to do that, but at least understand the output of those algorithms and have the overall idea of how actually on the high level these algorithms are working. So what statistics are required for us actually?
It kind of depends on your problem again, and I'll just give you an example. uh,
Hmm.
uh, so take example for any sentiment analysis or any kind of textual thing you want to do, like based on text you want to do um, let's
Classification.
let's just take sentiment analysis, right? So
Okay.
there are different approaches. One, the easiest one will be just keyword based approach, but then again, if you want to go to a machine learning path, you will probably use something called TF-IDF. So TF-IDF, or there are different approaches. For example, word of bag model. So what it does is that it takes like specific words, so very similar to how our keyword was working, but instead now it creates a specific, for example, just imagine a container. So maybe a paragraph, so a sliding window, it slides through all of them and takes the most frequently used words and tries to see if those words are positive or negative, these kind of things. So for these you don't really need that much of statistics, but then again, when you are actually encoding these, like what I am telling into actually a program, uh, you will need a very like overall knowledge. It's not something you really need to learn. So like I think what we learn in 12 should be enough for all these.
Okay.
But then again, if you go to different paths, for example, and these I think even Ankan and all of them use, I don't know how much. If you go into any kind of prediction based on signal analysis or any of these or any of portions, um, maybe image or image histogram, all of these, and you have to do Bayesian analysis or anything, then you need to have good understanding of what is going on. I think Ankan can talk a little bit better on this.
No,
Ankan,
I
you are
think
working on object recognition.
no, not really. But I mean, I did some statistics courses because usually wireless communication needs some sort of statistics background. Um, the thing is, if you consider a large number, or if you consider a big data set of anything, then and essentially what you need to learn is something called a law of large numbers. So you just go to Google and just search with the name law of large numbers. Okay. So what Ravimba is trying to say is you don't need to know the math.
Hmm.
It's a complex math. It combines variance and mean and all these kind of things. But parts of few things of those you have already studied. But regardless, if you know the statistics behind it, obviously it would be helpful. because the rule of thumb is if there is a large number of data anywhere, you can just model everything into something like a bell shaped curve. Okay, and then the center of the bell is sort of like a mean. So things like that. Once you go over the web and you search about this Gaussian distribution, you will know what it is. So again, you won't need to know the math. Obviously, it helps if you know the math, but for now you don't need it. But you would find models, you would find functions written in C, Python, any other language, or MATLAB for that matter. That all it does is basically asks you for some arguments, some input, and give you an output. And at the end of the day, you care about the output. How the math is working at the background, for starters, it doesn't matter for you. But then again, you can go inside and then you can start googling and then you can get to know more. But again, it's again up to you to what level of detail that you want to get into. If you want just the surface level information, or just want to get an output of it and then use the output somewhere else, then you can just do the function and then just get the values and then go with it.
So I think a lot of all of us will have this question regarding like there are so many things that, so you today you gave us remember you gave us the walkthrough of so many things like different types of machine learning, different algorithms, how people are using it. So for anybody starting out, it's quite intimidating to, means at least to me, it seems very intimidating, like so many things where to start. So you guys recommend any starting point where we can go and just start and not think about so many things, like there are so many information to process. So is there something like, how did you guys start? Like you also started sometime, right? How did you guys start with your program? Did a problem come to you? You went to seek a solution for it, and how did you start your journey in machine learning? So Ravimba, if you can start, then Ankan, you can
Well,
add your.
I started in a bad way. That is not a recommended way. Yeah, so we had to do it. Mostly, it's like you have to do it, so learn and do it, kind of stuff. But right now, if you want to learn and just go into it, so we were actually discussing. So there's a Google machine learning channel, so which they started. It's bite size, literally 10 or 14 minutes, and they go through all of these. Like so, each like first in their first and second episode, like which are 10 and 20 10 minutes, and another is 14 minutes. They go through all this very exact example of apple and oranges with Python code with scikit-learn, and after those 24 minutes you will be able to write you will write your program in this 24 minutes, which will differentiate between apple and orange with the data set they gave. So
Great.
So you can actually learn to code and all these very easily.
Yeah. Yeah, I think it's the same thing. I was actually about to say the same. You literally need no background of coding whatsoever. Just I will actually send the link, or Ravimba will send the link. It's exactly like 7 to 10 minutes each video. I think there are 7 or 8 videos in total, and that gives you more than enough information to get to a point where you can understand what Ravimba is talking about today. And those are very, very extremely simple. And those all of the videos touch like very important topics, but in a very subtle way, very, very easy way, and then anybody can understand.
Okay, great. I think that will be a good starting point for us. And I think some people are anxious to know whether Python is required for. I think there's a question from Asif.
Yeah. So you don't. It's language agnostic. You don't need to learn Python, or you don't need to learn any specific language. Having said that, most of the tutorials or codes you will find either probably will be in Python or R or maybe JavaScript, just because Python is easier to pick up. If I ask you to just the same code you will learn probably in Google or something, if I ask you to do that in C or C++, it's much harder for you to do that. And even with the existing libraries, it's much easier, like 1 or 2 3 lines to actually do that in Python with existing its own libraries as well. So it's just matter of convenience. It's not tied to any language. Some people find it easier with different languages. Yeah.
But R and Python is used by the community a lot, right? So it is very easy to understand if we have knowledge of these languages.
Mostly Python, R, and JavaScript even now, because
Okay.
oh well, if there is something which anybody did in any language, somebody has ported that to JavaScript.
Okay. Yeah, true that.
For,
That is true.
for people who are not from computer science background, I think I would suggest MATLAB. It is such a powerful tool because I come from a non-CS background, so I know the pain. It takes, because if you don't want to spend enough effort on learning a new language, although it's useful if you learn, but if you don't want to spend that time learning a new language, just open MATLAB and just Google different ML algorithms and things like that for MATLAB. Now it will help you in two scenes. One, you'll learn machine learning for sure. Second, you'll learn MATLAB for sure, because MATLAB will be used anywhere else, regardless, like industry wide. Even I'm using MATLAB today, and like day in and day out. So you will use MATLAB regardless of which field you go to later on. So it would be useful for you. And they have a lot of very interesting libraries and modules, and those are very up
They
to
have
date today.
ready-made toolboxes for most
Yeah,
of
they,
them
they
and
have really good
things.
toolboxes. They are GUIs and things like that. Even it looks better than Python. Trust me. So,
So MATLAB has any community edition or something? Because I think we used in Techno in our time it was all pirated.
So that was I was gonna tell you.
I think I mean, do we have any alumni in MathWorks?
You won't get
Or I mean,
MATLAB. You would get
what?
Right?
MATLAB.
That's the
You wouldn't
problem with
get
Yeah, you
MATLAB.
won't get MATLAB, but I mean, that should not stop you guys to get MATLAB, right? You should still get MATLAB.
So
So
since
it's up
I
to you where you get your MATLAB from.
yeah, so
My point
since
is how to use it rather not to get it. So if you
so
want to
I
know where to get it, then we should speak.
yeah, so I want to kind of pitch in because since I want to promote that, so unless Techno has changed something or they have license for MATLAB, probably you won't get it, or you will get
yeah,
some pen drive
but
version.
yeah.
Just use something called GNU Octave. That's an open source version that uses the exact same syntax as MATLAB, and that is essentially MATLAB with the exact
Yes.
same thing. Just the GUI is a little different. And if you
Yeah.
learn it, everything you do that is like 100% compatible with MATLAB. So learning part you can do that there.
Okay, so if we compare MATLAB versus these languages, which is easier to pick up? MATLAB or Python or R, Java, whatever the
MATLAB.
other? MATLAB.
MATLAB.
Okay. Fine.
MATLAB for sure. MATLAB. Yeah.
Okay. Okay, great.
It's
So
a it's
all
a
these,
one-stop shop. So you should get everything.
okay, great. So it's like all these use cases that Ravimba mentioned, right? So all these use cases can be implemented using MATLAB.
Yes.
Okay, and the
More or less, but yes.
Almost everything can be implemented. Just keep in mind that you are learning in MATLAB. Don't
yeah,
think this will be translate to like production things.
no,
Yeah,
that is
I would probably add one more thing. If you are going to use these kind of algorithms using MATLAB, you would probably need a faster machine. Okay, so because
oh yes, yes,
the
that
newer
is correct.
MATLABs 2014 and above, they use a lot of GPU power to do a lot of math at the background.
Okay, okay,
So yeah, you would need a powerful computer to run MATLAB. Anyways, for
okay,
Python, it's fine as long as you compile, it's fine. But then again, once you start crunching numbers, yes, you will need a powerful machine anyways. So yeah,
I'll share my screen for 1 second and
hmm,
yes. So as you see this page, so these are like demo application from MathWorks using different algorithms and anything. So you can actually see it can detect objects, it can detect specific objects and everything. So you have demo code of detecting car using Gaussian mixture model, using deep learning, using pattern matching, using text based on different matters. So all these are like already readily available, and these are not like too hard to actually understand. So you can just go inside, see the code, and like just play with it. It's pretty easy to pick up.
okay, okay, great.
there is one more question, I guess, Ravimba.
Yeah.
Web development project, better to go with JavaScript or Python?
Um. So there are two portions of it. Uh, First, my advice will be don't actually run a pipeline of model in a web application. If you have to do machine learning, do it either in a pre-trained model. So you train your model, you have everything, just pass it through in a server, not in JavaScript, not in client side. So run it in JavaScript somewhere. So if you're writing it in JavaScript, I mean in JS, then write it in a Node.js program, which you can run it in server. Or if you're writing in Python, then of course it's running in server somewhere or some machine, and you have a REST API to call and interact with it. So the thing you need to understand is that these models take a long time to train and take a long time to run. So the training part is more intensive. Once you have a trained data, it can be optimized to actually produce the results fast enough that you can use it in normal application. But you cannot run the whole pipeline while something is like while you are in the app. So keep that in mind. But yeah, it's still language agnostic. If you are writing it in JavaScript, just put it in a Node.js application. If you're writing in Python, put it like in server and run it as a Python application.
So for JavaScript, do we have all the libraries like we have in Python, like scikit-learn and all these things are there in JavaScript also?
There are everything. You will just have to search it, but everything that is there in Python, there is something.
In JavaScript.
Yeah.
Okay. I think Asif, does that answer your question? Okay.
Yes. Okay. Any questions?
So I think our next follow-up can be actually let's do something on our own, right? And then come up and get some knowledge of how things are working, and then we can have actually a detailed discussion on any one of the particular topic that we have worked on, and then we can actually utilize, you can vertically deep dive into some particular. Suppose if you use one of the Google's videos and try out some of their, then we have question on how it is working. Then I think Ravimba and Ankan and and start, because I believe that Google video and thing will show you like what to do thing working, but how it is actually working, I don't think they will be sharing, because and small sessions how to get the things working. Have very firm mind like how exactly this is working. I think then these guys can step in and answer. Maybe we got a good introduction, but to utilize their knowledge, we have to actually learn ourselves a bit more. So we can ask those kind of questions and satisfy our curiosity, because after after working with this for a while, we'll definitely have questions of how actually these things are working, like a magic, how they're mapped. So before that, we need to learn ourselves also. We can have a session after doing some projects, some learning. It can be different for each of for us, but we need we need to learn on a question, but uh, answer these guys work for a long time to learn. So then we can actually hope.
Yeah. I think you're getting disconnected for some reason.
Oh, okay.
Your voice is breaking. Okay.
Oh, yeah. So basically, I just want to sum it up as saying that I think we had a great intro to machine learning and learned some of the jargons which we had between machine learning, AI, and how these are interrelated. So right now, the action item is actually to do some work ourselves and then have a follow-up session.
Okay.
Yeah. I think Ravimba's feed has frozen.
Oh, I think so, maybe. Is it? Oh, Colonel Pine. Okay. So I think, yeah, I think his machine somehow shut down.
Okay.
It seems like there is no other question. Not in this topic, not in any other topic. Okay. It's just one round, one last round if somebody wants to ask anything before we shut down. So we're going to share a Slack. It's basically a messaging channel that we have for our alumni group. So we're going to share the link with Ashiv right now, and he's going to share it locally with you guys. What it is basically it's like a chat engine that people use industry wide. So all of us, or most of us, or at least few of us, will be online most of the time. So if you get online, just make an account. It's a free account. Just go on the web, sign up for a free account, and then you can just log in, and then you can shoot chat message or whatever. So I think that will be all. Yeah, thank you for attending.
Yeah, thank you guys for attending, and thank you Ravimba and Kan for organizing this.
Yeah, it was great.
It was great.
Yeah.
Okay.
All right. Bye
Bye guys.
bye.